The C programming language does more than just math. It can manipulate characters and words and things like that. In fact, it's so powerful at doing so that most operating systems, especially long ago and in the beginning, were written in C. The ability to take a command, a word, and do something with it, interpret that, etc. There are a lot of modern programming languages that are better at string manipulation right now, so it wouldn't be my first choice if that were my main job for a program, but it's still pretty powerful, and it's one of the many that can do string manipulation. So we're going to do a program that does that looks into characters and strings of characters. And to do that, it's going to be different than almost every program we've done before, and so let's start from scratch. Let's go into Finder, and then cd desktop, cd C code, and then we'll do /make project.sh space, and then sort, S-O-R-T. We're going to sort. We're going to do alphabetical sorting in this program. So then I do cd space sort, and then open dot, and it comes up in the Finder. The directory comes up in the Finder, and then I'm going to double click on sort.c, and it comes up, the template basically. Program comes up in Xcode. I need a new library, right? So I'm going to add a library up at the top. I'm going to do a hashtag include, then less than or greater than brackets, and do string.h. So the string library, it's a series of commands that can manipulate strings and characters. Okay, it turns out this library is important enough. I think I'm going to add it to the template as well because I use it quite a bit. And so I'm going to go into the template folder, double click on template.c, and add the hashtag include string.h command to the template as well. Save it and then close that up. All right, so the first thing we're going to do is we're going to add a new variable, and the variable is going to be alpha, and it's going to have 30 elements to it. It's going to be a character array. We've learned about, characters, cars, are a new type of variable. We knew about it from argv, right? So car space, then that star argv bracket thing. So we kind of knew that car was a new type of variable. It's a character, right? And so an array of characters is also known as a string. So you're able to have a whole bunch of characters. And in fact, in the printf command, when you do inside the double quotes, that's a character string. So we've seen character strings before. A character is anything that you can see on your keyboard. And there's even more on top of that. But basically, letters, numbers, symbols, all that stuff, those have character representations. So we're going to go into more into what that is. This program is just going to take a character string of letters, and it's going to re-alphabetize them and put A first and Z last, is basically what this is going to do. So the first thing to do is to load up the alpha character array with every letter, lowercase letter. And what I did was I went to my keyboard and I started at the top left, QWERTY, Q-U-E-R-T-Y, and then went all the way across the top row, then the middle row, then the last row. And so that's the order in which I did it. And so let's take that, the QWERTY order, and convert that just to regular the alphabetized order. We're going to learn an algorithm on how to sort stuff. So how do things sort things alphabetically? So that's something else we're going to learn. In order to do that, I had to do I used the string copy command, strcpy. So what that command says, take this alpha character array and put in it this QWERTY blah 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 in it. Good. And so that's in string.h. So I'm using that string command. And then I'm going to have a nested loop. So the nested loop I need two variables, two indices in order to do a nested loop. And so I and j. So the I loop is going to go from 0 to the next to the last point, 24. So it goes, if it's alphabet, they're 26 letters, so it goes 0 to 25. The inner loop goes from I plus 1 to 25. So when I is 0, j goes from 1 to 25. When I is 1, j goes from 2 to 25, and so on. And in it, it's going to say, it's going to swap the variables. If alpha sub j is less than alpha sub I, swap them. Switch the order. Hold on. Swapping characters. And if less than, what does less than mean? Okay, a character is the same size as an integer. And there is a numerical representation of every character value. It has a special name. It's called the ASCII character set, ASCII. And here's the table of the ASCII character set. You can see a whole bunch of different things and all the different characters. The first few are blank because they're control type characters. I think 7 is the ding, bing, right? And so it's a sound. An ASCII character can actually even be a sound. There's 128 on this particular chart. There's an extended ASCII character set that has more characters, and there's even more. Turns out there's tons of ASCII characters. Okay. Let's look at the important ones, though, the ones I really want to know about. First are the numbers. 0. So the way this chart works is the left-hand side is the numerical equivalent of, on the right-hand side, is what the character itself is. The middle is the hexadecimal equivalent of that decimal value, and so most computer nerds, a lot of computer nerds think in hexadecimal, some power of 2, right? 16 is the power of 2. I have 10 fingers, and so I usually just think in decimal, but whatever, right? And so 48 is, if you look at 48, that's the character 0. Wait a minute, 0? There is a difference between the character 0, that's what you type and what you put into a string when you want to type it out to the screen, and the numerical number 0. So there's a difference. There's a difference between the character representation of a number and the number itself. That's a key component, and so that gives us a hint as to what a character is. There's the representation of it in terms of strings. So the printf statement, we've already seen a character string in the double quotes. That's a character string. That can have zeros in it that aren't related to, that don't have any numerical equivalency. It's just a 0 on a screen. The other key characters here are the alphabet characters. 65, capital A is 65, and it goes all the way down to capital Z. And then lowercase a is 97. So lowercase numbers are just the uppercase numbers plus 32, right? I'm only dealing in lowercase in this particular example, right? So if you wanted to switch between uppercase and lowercase, you would just add or subtract 32 to it. And lo and behold, capital B is equal to 66 and capital A is 65. So B is greater than A, right? And A is less than B. Capital A is less than capital B. Lowercase a is less than lowercase b. So the lower numbers are earlier alphabetically. And so that we're gonna exploit that we can compare the numerical values of characters to alphabetize them. Okay? So that's what this code does. So if alpha sub j is less than alpha sub I, right? If the character that's later in the sequence is less than the character that's earlier in the sequence, then that means it's earlier alphabetically, then swap them. And so the three commands there are swapping. If each variable, alpha sub I and alpha sub j, have something in them, you need a third variable to be able to swap them, right? So I have this new array car space temp up at the top. And so like if your left hand has a dime in it and your right hand has a nickel in it and you want to swap them, well, you need a third hand. So you take the dime. You can't have two coins in your hand at the same time, right? So you take the dime and you put the dime in the third person's hand. This is the second person's hand, and then take the nickel in your right hand, put it in your left hand with the dime, and then the person's third hand in this little thing then puts the dime back in the right hand. So now the dime's in the right hand and the nickel's in the left hand. You switched, but you need that temp. You need the temp character, the temp variable to help you with that. So that's what that is. That's that little swapping mini algorithm. Notice that I did the indentation. So the if statement's indented, and the if I loop is indented, and j is indented, and all that, and then the if statement's indented even further from that, so that it makes it clear. This nested loop is what it's called. It's clear to the user what's going on. That's it. That's the whole algorithm. So let's go back into the terminal and we compile it and run it. And notice I added the these printf statements above, so you can see before sorting. And then when I wanted to print it out the alpha, the character array, I just use %s. %s is for a character string, %c is for an individual character. So those are two new % characters that you will have learned. The other thing to note about this algorithm is that there's an if statement but no else. So if alpha sub j is greater than alpha sub I, don't do anything. Just leave them in the order that they're in. And so there's an if but no else. So again, we go back and we compile it, we run it, and then you'd see the printf statements before sorting and then after sorting, and you can see that before it's QWERTY, etc., and afterwards it's ABCD all the way to Z, and it's all sorted, and so the program works. That's it. Now, we learned a lot. We learned this special type of sorting algorithm. It's called the bubble sort. It's not the most efficient sorting algorithm, and computer scientists have a whole bunch of different types of sorting algorithms, so this is just one of the many, the bubble sort. And then we also learned about characters and strings of characters and the ASCII character set. So we actually learned quite a lot in this video.